All right now, everybody, we are dealing with Chapter 1, Section 5. We're dealing with parent functions and transformations. The first four functions I want to make sure that you have in your journal are this constant function, the identity function, the quadratic function, and the cubic function. These are very common functions that you deal with. Now you'll notice this constant function right here is about how high up on the y-axis. What would you guys say? How high up am I? 3.5. So we're about 3.5. So basically you would say y is equal to 3.5. Another way you could say it is f of 3.5 is just 3.5. You can see it constantly stays 3.5. If you were to go to your graphing calculator and hit the y equals button and type in 3.5, we clear all these out. Get to these later. When you type in 3.5 right here and hit graph, you'll see that line goes straight across the screen, across the screen path. Across the screen. That's what I was thinking. Where y is consistently equal to a 3.5. Okay? The identity function is this one right here. This is f of x equals x. You could also say y is equal to x. Every time you see f of x, I want you to think that's your y value, because y is a function of x. If you wanted to see what that looked like, you could hit y equals and just change it to x. I'm going to hit zoom 4. There's your identity function. The next function is your quadratic function. This is f of x equals x squared. Graph. That's your parent function. All of these, everybody, all of these are considered to be parent functions, okay, where they start out at. All right? And last, on this front page, is the cubic function. X raised to the power of 3, or x cubed. You hit graph, and you'll see this cubic function right here. This is y equals x cubed. Just like this is y equals x squared. Alright. Next thing we're going to do, we go to the next page. And right here we have two other parent functions. We have the square root function and the reciprocal function. Alright. So the square root function is y equals the square root of x. F of x equals the square root of x. And you have y equals 1 over x. So one thing I want you guys to have in your journal, you want to have the name of the function, you want to have the equation that goes with it, and you want to have the graph of that function. Those are the three things you want so that you can easily identify what they are. Then we'll worry about the second part, which is the transformation part. Okay. Change this. We'll type in the square root of x. There's your graph of the square root function. That's the parent function for all square root functions. And then we'll clear this out. I'm going to go parentheses 1 divided by x, close parentheses. That's one way that you could type it in. You could also do alpha y equals enter. Do 1 over x. Take a look at it. Now, anytime you do a fraction in the calculator, you'll notice that all of your y values in your table are also fractions. So you can kind of see how it's the reciprocal function. What's the reciprocal of a negative 4? Negative 1 over 4. What's the reciprocal of a negative 5? Negative 1 over 5. So you can see that this is a reciprocal function. So that makes it a little bit easier to understand why they call it a reciprocal function. However, if you put it in parentheses and do 1 divided by x and you check the table, it's not going to be in the form of a fraction. All of them are going to be what? Decimals. Makes it a little bit harder to understand why they call it a reciprocal function. All right, the next two. All right, here's the absolute value. That's one of them that you need to be able to draw. All right, now this is how you would type in absolute value in the graphing calculator. All right, if you want to see this function in your calculator, you hit y equals, to clear this out, hit the math button, go to number, and hit the number 1. That's one way to do it. So what did I say? Hit math, move over to where it says number and choose ABS, number 1, absolute value. Okay, that's one way to do it. Now, a faster way to do it would be to go alpha window, enter. That's another way. You can say alpha window, enter, and still get that absolute value bar. I'm going to hit y equals absolute value of x, hit graph, and there is your function. Okay? Right here is this one right here. Okay? The greatest integer function. Okay? This is also referred to as a step function. So if I say graph this step function or graph this greatest integer function, you're dealing with the same concept. Right? You can kind of see how it goes up by steps. By the way, what's the only thing that is graphed as far as y values? What's the y value right here? Just the y value, not the x. Just the y. -4. What do I hear? You guys notice the only y values that are being plotted here are technically integers. Now, all the numbers for x are being plotted. All the little fractions in between are being plotted here, but what happens? It jumps up to the next whole integer, the next whole integer, the next integer. Okay, that's why it's called a step function. Now, how would we do this in the graphing calculator? Hit y equals. Clear this out. You must hit the math button, move over to the right, and you need to go down to number 5. So math, move the right arrow over once to where you have the number, and you're choosing to do what's called number 5. And now I want you to put in an x. Right here. Now hit graph and take a look at it. Now, look carefully. You see how the x value is plotted right here, but right over here there's a little bit of a space. So it'd be kind of cool if they put an open circle. That'd be awesome. But this graphic calculator doesn't have that feature yet. I'm sure they will at some point. So the greatest integer function goes from right here, but it does not include this x value, and then it jumps up. So this is how I want your graph to be in your journal. This is the parent function for all step functions. Now, you guys may not be aware of this, but you actually, who here has a job? Ooh, you guys need to know step function because our tax system is a step function. If you look up taxes, you pay a percentage. You start at 10% up to a certain amount, and it jumps up to 15%. Depending on how much you make, and then it keeps going up and up and up and up. Gets up to, I think, over 33%. All right, so if you're a millionaire, some of your taxes are going to be paid at 33%, but not all of them. Okay, so you could look that up. It's the federal taxes are a step function. All right, we're going to be talking about two different types of translations. One of them is called a vertical translation. The other is talking about a horizontal translation. Vertical is dealing with what? Going what? Up or down. Okay, right. Horizontal is dealing with sliding it what? Left or right. Yeah. So we want to do is I want you to understand this blue function right here, and this blue function, and this blue function, and this blue function. Let's just pretend. Let's just pretend that's y equals x squared. So in your graphic calculator right now, go to your graphic calculator, hit y equals, and just type in x squared. Hit graph. So all of us have this parent function. And what is this parent function? A parent function of all, yeah, it's parabola. Good job, Tim. All quadratic functions. All right, we'll go back to our paper. Now, let's pretend, everybody, that this right here, this graph, g of x, is the same as f of x, so that's x squared, except we're going to add a constant. So what if we added a constant of, say, I don't know, 2? All right, or a constant of 3. That simply means that this constant number right here, I'll put the word constant, that means this graph is going to shift 3 units going up. So go to your graphing calculator, hit y equals, let's go down to y5, since it's green. And let's type it in x squared to put plus 3. Take a look at it.
Oh.
See it? Everybody see that? Oh, I here's what you want to type in. Ready? Hit the y equals. You're going to go to y5, which is where the green one is. You're going to type in y equals x squared plus 3. And what is this graph originally? This is y equals x squared. So what was our k value? Our k value is 3, so it moved it up 3 units. Okay? Now, let's go back. If that goes up 3 units, what could we do with this one? We could say g of x equals x squared, and let's say we went down. How do you want to say? How do you want to go down? 3? Okay. You want to go 4? We can go 4 if you want. Go down 4. So what does that mean? That means this constant right here is telling us it's being translated vertically down 4. So go to your graphic calculator, hit y equals, go to y2, type in x squared minus 4. And you'll clearly see that this graph goes down 1, 2, 3, 4 units from y equals x squared. So this right here, this k value is making the graph go up. This k value is making it go down, depending if it's plus or a minus. Okay, now this is where it gets really fun because we're dealing with horizontal translations. And you'll notice that this graph over here, which direction did it go from blue to go over to green? Which direction? It went right. So this is going sliding to the right. So right now what I'd like you to do in your graphing calculator is I want you guys, we're going to write g of x equals, we're going to go parentheses, we're going to say x minus 2, and we're going to square it. So what I want you to do is in your calculator, I want you to hit y equals, I want you to do parentheses x minus 2 squared. So let's go to our calculators. I'm going to hit y equals, I'm going to clear out this red graph. I'm going to go down to the green, and clear it out. Open up the parentheses to x minus 2, close parentheses, squared, and hit the graph button. Now let's take a look at this. My original graph is right here. That's where the vertex is. Now this vertex has done what? It's gone over 2 units to the right. Now this is where students get confused. And hopefully this will help clear things up. Does everybody agree that this graph is y equals x squared? You say yes. All right. Where is this vertex at? This vertex is at 0, 0. Where is this vertex at? Right there. That's at 2, 0. Well, what number would you have to plug in for x to get it back to 0, 0 and not 2, 0? You actually have to plug in the number 2 That's why this graph went 2 units to the right. Where students get confused and they think x minus 2, what do they think? They think we're shifting it 2 units to the left. When actually, don't focus on the minus 2, focus on what number minus 2 gets me back to 0, 0. Okay? So if I change this up and hit y equals and went over here and said not x minus 2 in parentheses squared, but it's x minus 3, that's now going to shift it over 1, 2, 3 units. So if we want to shift a graph horizontally, this right here is going to shift the graph which direction? It's going to shift it to the right. Whereas, if I have g of x equals parentheses x plus 2 squared, what number would I have to plug into x to get me back to 0, 0 in this particular case? Negative 2. So that means I'm going to go negative 2 units. Right? When it's negative 2 units means I'm going to be going 2 units which direction? 2 units to the left. So right now, go to the graphing calculator. Hit y equals. Go down to y2 and type in x plus 2, close parentheses, squared. And hit graph, and you'll see a red graph that has gone what? 1, 2 units to the left. All right, we're going to do a quick little quiz here to see how y'all do. So here's our parent function. This is a cubic function right here. What would happen if we change this cubic function to x cubed minus 2? What do you think is going to happen to this graph? It's going to go down 2 units. So this function is going to translate 2 units down. So if I said write a verbal description of what's going to happen, you would write the graph moves 2 units down. And it would look like this. From here to here. Fancy, huh? Fancy. I'm telling you. Actually, no. The company, I found the company that did it. No, I didn't because we bought this. Our school bought this. I'm using the resources that the school bought me. All right? Mr. Lampick has the resources. Well, not it. School has the resources. We have the receipt. Just trust me.
I love how you're still recording.
Now, everybody, this is y equals x cubed once again. Ooh, this is in parentheses. What number? Minus 1 would get me back to 0. Positive 1. So which direction is this going to go? To the right. How many units? 1. So it goes 1 unit to the right. And voila, there it goes. 1 unit to the right. All right, here we go. Tricky. Now we're dealing with horizontal and vertical. Can you stop looking at yourself in the mirror, Kaden? Thank you. All right. Now, were you not looking at it? There you go. All right. Right over here. What kind of translation does this deal with? Horizontal or vertical? Horizontal. What about this one? Vertical. So what's happening, Kaylee, up here? Tell me about this translation. Don't worry, I'm not recording. Yes, your eyebrows look fabulous. So, what number minus 1 gets me back to 0? What number? That's right. Right now, everybody. The number that I would plug in there to get this right here equal to 0. 1 minus 1 equals 0. What does that mean? That means this is a horizontal translation, 1 unit. Which direction? Yes, to the right. Good job of seeing that R there that I was writing. All right. Now, what does this part of the graph mean? That means we're going down 2. So we're going 2 units down. Everything else in the function stays the same. So this is the exact same function. All that's going to happen is this point is going to go what? 1 over and down 2. This point right here is going to go 1 over and down 2. This point right here, 1 over, down, 2. And then your graph is going to follow this pattern. Now, it'll look a lot prettier than this, okay, because I'm just doing that by hand. All right, so let's check it out. 2 units down and 1 unit right. There it is. Okay, let's see how good that was. Probably not very good. Look at that. Hey! You don't have to say that out loud. Hey, it's not bad. It's not too bad. Not too bad. I am recording. I'm totally recording right now. I'll prove it. See? Look right there. It's recording. All right. All right, guys. Don't tell me the answer. I'm going to give you guys 10 seconds to choose an answer and write it on your paper. All right. If you're watching this video, you should have paused it. All right, because we're about to say the answer. So on the count of 3, everybody, we're all going to say the correct answer. 1, 2, 3.
B.
Wow. Some of you are right. Some of you are wrong. Well, let's see. Right now, what is x minus 2 squared? What type of translation are we dealing with? Horizontal. So what number right here would get this right here equal to a 0? A positive 2. So that means 2 units going to the right. What does this negative 1 mean? This is dealing with what type of translation? Vertical. So it goes over 2 units to the right, 1 unit down. So let's see here. Over 2 units. The correct answer is going to be B. Let me find out. So right there.
You should check that.
But I'm not. So right here, 2 units to the right, 1 unit down, and that is your final answer. Ooh, last part of your notes right here. This is it. This is the last part of your day. Right now, write these down. This is dealing with reflections across the x-axis. You don't have to make that arrow that big. All right, and reflections across the y-axis. Let me shrink that just a bit. Across the x, across the y. Nope. Third time's charm. Nope. Fourth time's charm. Got it. All right, so everybody, right here where it says g of x equals negative f of x, that means all your y values are now becoming negative. You're making all the y values negative. All y values negative, or the opposite of them. Okay? All y values negative. We're still recording. Next thing over here, if I say g of x equals f of negative x, what's happening to all the x values? In the parentheses, what's happening to all the x values? All x values are becoming what? Negative, or the opposite of whatever they are. Okay? So that what happens is these reflect across the y-axis, and this reflects across the x-axis. So that's the last thing you need to do on your paper.